Okay, we are continuing with the same example like before. Y is price of unleaded gasoline per gallon, and X is the price of crude oil per barrel 1 month prior. Okay, so for us to be able to test, we have to make the assumptions. Okay, let's look at the assumptions one more time, one by one. So expected value of Y is beta sub 0 plus beta sub 1 X. So the value of Y, the mean value of Y falls exactly on a straight line, and the actual value of Y is this mean plus an error term epsilon. Then the expected value of the error term is 0, so there is no bias. Okay, and the errors are independent of the price of crude. So going from one period to the next period to the next period, the errors are independent. This is the assumption that may be a problem. We will look at this later on. So the variance of the error term are all the same irrespective of the value of X. And number 4 is the error term follows normal distribution for all X values, the crude oil price per barrel. That's the 6th assumption. Okay. Then given these assumptions, we want to test whether the slope here is 0 or not 0. Not equal to 0. Oh, let's change the font here. Okay. Now, is equal to 0 means regression is not significant. Okay. Now, not equal to 0 means the regression is significant. Okay. Let's assume 5% alpha value. And now B sub 1, we know B sub 1 from here, or we can use that one, either one. It doesn't matter. Okay. Now S sub B sub 1, the formula for S sub B sub 1 is S over square root of the denominator of B sub 1. So here is the formula. Remember, S is the square root of MSE, and we have already computed S right here. And the denominator is square root of that, and you see that is the denominator of the formula for B sub 1. So here is the formula for B sub 1, and you see the denominator is that, and we have to take a square root. So we start with S, okay, which is here also, and we computed S right here, divided by square root of the denominator for B sub 1. So that's our S sub B sub 1. Now take B sub 1 divided by S sub B sub 1 will give us the value of T. Now we can do the same thing from the output, regression output, data analysis. So here B sub 1, so here is the regression analysis. B sub 1 is right there. Okay. And right next to that is your standard error. Okay. Again, you see it's exactly the same value. And then the T, you don't even have to divide B sub 1 by S sub B sub 1. This T value is also available here from the output, which is right there. Okay. Now the degrees of freedom is always from MSE. So MSE degrees of freedom is that. And again, regression output also gives you the degrees of freedom. So here is the degrees of freedom. You know, with this, we should be able to complete the test. Okay, now let's do a t-test. For that, we can either use the t-table value or we can use the p-value, either way. So let's first use the t-table value. So t-table value is given by, this is a two-tailed test, so t dot inv dot 2t, and the first argument is probability, that is alpha, and then degrees of freedom. So this gives us the t-table value. Now t calculated value is greater than t-table value, therefore we reject the null hypothesis. So that's our conclusion. Now we can also use the p-value. The p-value for a t-test, two-tailed t-test, is given by t dot dist dot 2t. Okay, and then we take the absolute value of the t, okay, and then the degrees of freedom. Okay. So this will give us the p-value, and this simply means it's a very, very small number. This is 3.06 10 to the power of minus 97. That's what that is. So we'll convert that into percentage and you say it's 0%. Okay. So that again means we reject the null hypothesis. So since p-value is less than 5%, we reject the null hypothesis. So we can now make a conclusion, interpret the conclusion, and we can say that there is sample evidence to conclude that the regression between unleaded gas price per gallon, okay, as the dependent variable, and the crude oil price per barrel 1 month prior, that regression slope coefficient is not 0. And the probability that this conclusion is wrong is nearly 0. So we are almost certain that there is a slope that is not different, that is different from 0. So here is the interpretation for us. We can also do the same test, okay, only in the case of two-tailed test. We can do an F test as well. Okay, now F test is MSR divided by MSE. So we can go here to the top where we have found MSR and MSE. So here is MSR divided by MSE. So that will give us the F value. Okay, so that is from formula, but you can also do this from the output. Okay, from the output, that is the data analysis output, you see here, that's our F. So they both are the same. Now degrees of freedom, numerator is MSR, so numerator degrees of freedom is that, denominator degrees of freedom is C62, and then the F table value is F dot inv dot RT. Okay, first is probability, which is the alpha value, okay, which is right there, comma the 2 degrees of freedoms, that one and that one. So now we know that F is greater than the F table value, therefore we reject the null hypothesis. Okay. Now we can use a p-value test. So p-value will be F dot dist dot RT. Now here the F calculated value and then the 2 degrees of freedoms. So that will give you again the same very small probability. Okay, so we reject the null hypothesis. So since p-value is less than 5%, we reject the null hypothesis. Here we need to note something. This F value is actually t squared. So if you take the t that we got from the previous case right here, if you square it, you get the F value. Okay. Now all this is when beta sub 1 is equal to 0 against beta sub 1 not equal to 0. What if you're doing a one-tail test? In that case, the t, you can't do an F test, you have to do only a t test, and the t test Excel formulas will be different, and I have given those in the Word document. So here if it is if the alternative is greater than 0, then we use t dot inv 1 minus alpha. Okay, so here is the t. So 1 minus alpha would be the probability to the left, okay, and that will give you the t value there. And t dot dist dot rt will give you the p value. Now if it is less than 0 as the alternative, then your t value will be, okay, it is a minus value, so that will be t dot inv alpha on the left side. So this will come out to be a negative value, okay, and the p value is given by t dot dist t degrees of freedom, and you need this 1 to indicate that it is a probability that we want. It's not a height of the distribution. So this is somewhat different from these two t functions, dot 2t and dot rt. You don't need that comma 1, whereas in t dot dist function you need that. Okay, so study this. This table gives us the different functions that we need for the t table value and the p value.